This video is for class 7 physics and today's topic is regular and irregular or diffuse reflection. So going to the first one, that is regular reflection. The reflection of light from a smooth and polished surface such as a plane mirror is called the regular reflection. If a parallel beam of light is incident on a plane mirror, the reflected beam of light is also parallel and it has a fixed direction, as shown in the figure 4.11, right? So here let us understand regular reflection. So in a regular reflection, right, what happens is when the incident rays are parallel to each other and when they strike the plane surface like plane mirror, smooth surface, here we can observe that the reflected rays are also parallel to each other. So when the incident ray strikes a smooth plane surface such that the reflected rays are parallel to each other, that kind of reflection is called regular reflection, and this kind of reflection is responsible for the shine or produce glare of the object, right? It is not good for our eyes because the shine and glare for a long time can damage our eyes, right? Now going to the next topic, irregular or diffuse reflection. The objects other than plane mirror are not perfectly smooth, that is, they have uneven surfaces. When a beam of light falls on such a surface which is not perfectly smooth and polished, such as wall, wood, paper, cloths, cotton, anything, right, other than this plane mirror or polished surface, highly polished surface or highly painted surface, other than them, all objects are rough, right? Microscopically it is rough, so they produce irregular reflection. The different portions of the surface reflect light in different directions. Such a reflection of light from an uneven surface is called irregular or diffuse reflection. For a parallel incident beam, the reflected beam is not parallel. Thus, it is the diffuse light obtained after reflection from the uneven surfaces of the object which enables us to see them and their surroundings. Now, this can be understood with the help of this figure here. Here what we can see is the incident rays are parallel to each other, right, and they are striking a rough surface. But what happens here, this reflected rays, these three rays are not parallel to each other, right? So this kind of reflection where the reflected rays are not parallel to each other is known as irregular or diffuse reflection, So this kind of reflection is responsible to produce a general illumination, general vision. You can see the objects without harming your eye, without having any difficulty, just because of this irregular or diffused reflection. Coming to the next topic for class 7 physics, uses of plane mirror. Some uses of plane mirror are as, number one, as a dressing mirror. As you all know, you have a dressing mirror in your house, right? It is made up of plane mirror. Number two, in the optician's room, to double the effective length of the room, a mirror is kept on the opposite wall of the room. Okay, when you go to the optician room, you are made to read one kind of board. Well, this kind of board, right? And opposite to this board, mirror is placed, right? This will be your position, right? And actually you will be looking at the mirror to read this board, right? It is used in the optician room also. Now we can go to the next use. Use number 3, which is in a barber's shop. For seeing the rear view at the back, two mirrors are fixed on the opposite walls facing each other so that you can see the back of your head also. Okay, so let us try to see one image. So here is one image of the barber shop. Here what you can observe is you can see the image of a mirror inside the mirror, right? This image of the mirror is must be the mirror placed in front of this mirror right here. So these parallel mirrors are kept so that you can see the back of your head in this particular mirror, a mirror inside the mirror, right? So this is used in barber shop. Also going to the next use, which is number 4. It is also used in periscopes, kaleidoscope and solar cookers. Plane mirrors are used as the reflectors in all three kinds of instruments, right? So you can see these images, see the images of these kinds of instruments: periscope, kaleidoscope and solar cooker, right? So you can see the images, right? And you can ask me some questions regarding this. Number 5, sometimes as a rear view mirror in the front of the driver in a vehicle. Okay, so it is used in the vehicle also. Now going to the last topic from this chapter, that is light energy. Speed of light. Light travels in vacuum or air. It doesn't need anything to travel, right? It can even travel in vacuum. A distance of nearly this number here, right, meter, or nearly I can say 3 followed by 8 zeros. 3 followed by 8 zeros in 1 second. So it is the fastest thing in the universe. Thus the speed of light in vacuum or air is 3 into 10 to the power 8 meter per second nearly. It is the maximum speed of light. In a transparent medium such as water, glass, etc., the light slows down. The speed of light in water is 2.25 into 10 to the power 8 meter per second, and in glass it is 2 into 10 to the power 8 meter per second. Thus, light speeds up while passing from water to glass to air. So, speed of light in different medium here. Air or vacuum, it is 3 into 10 to the power 8, highest value. Then we have water, which is 2.25 into 10 to the power 8, and glass 2 into 10 to the power 8. This 10 to the power 8 is not changing, right? Okay, this is all for the chapter light energy.